Good afternoon, Doc Orma. Good afternoon, classmates. I was tasked to discuss to you these topics: the introduction of statistics as applied in education, and the definitions and concepts of variables and measurement, and the different level of measurement. But before we start, let us know first the objectives that we need to obtain after the discussion. Here are the objectives. First, understand why we study statistics. Second, know the origin and meaning of statistics and its application to education. Third, explain what is meant by descriptive and inferential statistics. Fourth, discuss between a qualitative and quantitative variable. Fifth, describe how a discrete variable is different from a continuous variable. And last, distinguish among the nominal, ordinal, interval, and ratio levels of measurement. We, the MAED 220D, the first time that we see the subject statistics is that we look nervous because we assume that these are a lot of numbers that we or that sometimes that we cannot recognize. But yes, it's too hard for us to look and imagine. But you know what? Statistics is the main reason why most of everything tends to be easier, because statistics are everywhere. Even when you go to a mall and want to purchase something, for example, a cell phone, of course, we as a practical buyer, you tend to canvas and search first the different brands and specs that rely on your budget. And through that, statistics gives you a better understanding on what product you're going to purchase. I know that some of you are also purchasing in Shopee or Lazada, that sometimes before adding to cart, you try to look whether the shop is on what rank of supplier. Nirarank din po sila kung top 1 to 20 yung brand supplier sila. And because of it, statistics will help you make better decisions in availing the product. So, as statistics can be organized, it organize the data, analyze data, present data, and interpret the data. And through this, a person can make his or her final decisions or conclusions. Again, statistics is the science or methods of collecting, organizing, presenting, analyzing, and interpreting data to assist in making more effective decisions. By the way, the word statistics seems to have been derived from the Latin word status, or the Italian word statistica, or in the German word statistik, which means political state or government. And the father of statistics is Sir Ronald A. Fisher from 1890 to 1962. Now, let us know the application of statistics in education. First, it makes the teaching and learning process more efficient. The statistics in education, with special considerations to the measurement and evaluation of concepts, are very essential parts of teaching and learning process. In this process, scores are being obtained and interpreted by the teachers to make decisions. So, statistics, therefore, it enables one to study these scores objectively. Next, it assists significantly in the collection of data and information. Statistics aids in the prediction of future events. For example, in a class of 89 students, their performance in continuous assessment and test could determine who will take first position or who will come out with overall best result. It could even predict the most intelligent student among the 89 students in the class, and this is what statistics can do. Next, it also helps in the summary of results. Statistics in education is important because it enables the calculation and adequate summary of the results in a meaningful and convenient form. Statistics gives order to the data. Again, statistics helps one to make the data precise, concise, and meaningful, and to express it in a way that the persons involved will understand easily. Next, it gives also an information about the school's population change. For example, the statistics in enrollment and dropout rate. And last, statistics analyzes the achievements and grades of our students and also in preparing of the test of our students. So there are different types of statistics. First one is the descriptive statistics. This one is a method of organizing, summarizing, and presenting data in an informative way, while the inferential statistics is a method used to estimate a property of a population on the basis of an example. Now, what is the difference between the population and sample? A population is the entire set of individual or objects of interest or the measurements obtained from all individuals or objects of interest, while a sample is a portion or a part of the population of interest. So, next, this one is an illustration of population and sample. So, for example, your population are the grade 7 students in your school. Then, your sample are the ones who include in the honors. On this picture, it will show you the difference between the descriptive statistics and inferential statistics. So from the population, you will get a sample. You will get a sample, and from the sample, you may now organize, present, and summarize their information or the data. And that is the descriptive statistics. Now, if you are drawing already the conclusion about a population based on a data observed in a sample, that is already an inferential statistics. Alright, so let us proceed on the variable. A variable is a characteristic under study that assumes different values for different elements. A variable on which everyone has the same exact value is a constant. Okay, and the value of a variable for an element is called an observation or measurement. There are actually two types of variables. First one is the qualitative, which is a non-numeric or attribute, meaning it cannot be counted or cannot be measured. And then the other one is quantitative. It is numerical, meaning you can count on it and you can also measure. Okay, next. So this one is an example of qualitative variable. A qualitative variable cannot assume a numerical value but can be classified into two or more categories. So as you can see, a qualitative variable can be categories of different types of trees, different types of aircrafts, and different types of animals. Next is the example of quantitative variable. Again, these variables whose values result from counting or measuring something. Examples can be height or height in inches, science aptitude, and price of houses. There are two types of quantitative variables. What are those? First one is the discrete variable. It is a variable whose values are countable. In other words, it can assume only a limited number of values with no intermediate values. The other one is the continuous variable. It is a variable that can assume any numerical value over a certain interval. So, let me give you an example. On this example, you may see on the discrete variable that there is an exact number that can be counted. So, this segment is just only from 0 to 6. Example of a discrete variable are unpopped kernels of popcorn in a bag, class size, family size, and calories in a hamburger. On on the right side, the example is the continuous variable wherein you may notice that there is a line or the line is continuous going to the left and going to the right, meaning it can assume any numerical value. So examples are age, can be weight, height, time it takes to go to school, temperature, and grade point average. Next, let us proceed to the levels of measurement. There are actually four levels of measurement. Let us start with the nominal. Nominal is the data. The date wherein the data categories are represented by labels or names. Even when the labels are numerically coded, the data categories have no logical order. So example of nominal level of measurement are the following. It can be an eye color, a gender, or a religious affiliation. Next is an ordinal. These data classifications are represented by sets of labels or names. It can be high, medium, or low that have relative values. Because of the relative values, the data classified can be ranked or ordered. Example, during the taste testing of 4 soft drinks, the Mellow Yellow was ranked as number 1. Next to that, as number 2 is the Sprite, third is the 7 Up, and fourth is the Orange Crush number. Third level of measurement is the interval. It is similar to the ordinal level, with the additional property that meaningful amounts of differences between the data values can be determined. But there is no natural 0 point here. Example, the temperature on the Fahrenheit scale. And last level of measurement is ratio. In here, the interval level with an inherent 0 is starting point. So you will always start at 0. So the differences and ratios are meaningful for this level of measurement. Example is a monthly income. So on this animation or illustration of 4 levels of measurement, let us start with the nominal. For nominal, the example is gender that can be a man or a woman. For the ordinal, the example is a position in a race from first to fourth. Next, for the interval, the example is the temperature in Fahrenheit, wherein you may notice that there is ordered and has equal differences, which is 10. So, from 0 to positive 10, the interval is 10, and from 0 to negative 10, that is also 10. So, that is their equal differences. And for the ratio, example is money that starts or always starts from 0 going to above. So in here on this example, it starts from 0 to $500. So that's the end of my report. Thank you for listening.